Hey guys, let's talk about graphing some linear inequalities. So, linear inequalities, the big difference is it's not an equation, it's an inequality. So instead of having y equals, we're going to have some sort of inequality here instead. So it's going to be very similar to graphing lines, but there are going to be a few changes along the way, and we'll address them once we get there. So first off, let's just treat this as if it was y equals negative 3x plus 6. Let's plot some points. So if I have negative 3x plus 6, I can recognize easily the slope is negative 3 or negative 3 over 1, y-intercept of 6. So I'm going to put a point at 6, and I'm going to start applying my slope. So my slope is negative 3 or negative 3 over 1, which means I go down 1, 2, 3 over 1, down 1, 2, 3 over 1, down 1, 2, 3 over 1. And I could keep going forever and ever and ever down here and say go up 3 and left 1. I could do all that if I so desired. I just don't need to, and I'll show you why here in a second. The big difference, first off, in linear inequalities versus linear equations is we have these inequalities, less than, greater than, less than or equal to, or greater than or equal to. These are less than or greater than. These are less than or equal to and greater than or equal to. Notice it has almost the equal to, or it does have the equal to in that statement. So these are still going to look like solid lines. While over here, we're no longer equal to that, we don't exactly want the line. And what we're going to do is we're going to use dashed. So less than and greater than, we're going to use dashed. Less than or equal to, greater than or equal to, we're going to use solid. So this first equation, or first inequality, we have y is less than negative 3x plus 6. I have my points, but because of the inequality, I need to have a dashed line. So what I'm going to do is line up my points. So we use something straight here, my D works. And I'm just going to make a dashed line along those points. Okay, we're almost there. The only other thing we need is we need to figure out shading. So with these inequalities, not only are we going to have solid or dashed lines, we're going to shade. So notice there's kind of, my graph is split into two. I have a left side and I have a right side. So I got to figure out where in the world is the shading. Is it on the left or is it on the right? The easiest way I deal with this is I figure out, first off, where is 0, 0, which is right here, currently on the left side. What I'm going to do is I'm going to plug in these coordinates. Plug in these coordinates 0, 0 into this inequality. I'm kind of testing a point. And you might have seen us testing points with just graphing basic inequalities, not linear inequalities. So I'm going to plug in 0 for x, plug in 0 for y. So I have 0 is less than negative 3 times 0 plus 6. So simplifying the right side, negative 3 times 0 plus 6, that's 0 plus 6, which is 6. Left side is 0. Looking at this inequality, I got to think, all right, is this true or false? Is this statement true or false? Remember, inequalities need to open towards the bigger of the two numbers. So you got to ask yourself, well, which one's bigger? And that's the 6. So since it's opening towards the bigger number, it is true. So how are we going to use that to figure out the shading? If it's true, we're going to shade towards 0, 0. If it's true, notice it starts with a T, we shade towards, also a T, 0, 0. If it was false, I'm going to shade away from 0, 0. F for false, F for from. So if it's true, we shade on the side that has 0, 0, which is the left side. If it was false, we'd shade away from 0, 0, which is the opposite direction over here. Now don't try and memorize, all right, true is on the left, false is on the right. It depends on where your line is. So true, go towards wherever 0, 0 is at. If it's false, go on the opposite side of 0, 0. Don't try and memorize it any other way because depending on your line, that's going to change kind of what side has 0, 0. So since this was true, we're going to go towards the 0, 0. So I'm just going to do some light strokes here with my pen, shade everything over here. Now what that means in this entire shaded area is any point in this shaded area is a solution to this inequality. So if I pick this point way over here, that's in the shaded area, that's a solution. Okay, so let's do one more problem just to make sure we got this down. I have y is less than or equal to 2/3 x minus 3. So I can start with some points. I have my y-intercept at -3. And I have my slope of 2/3. So up 2/3, up 2/3, up 2/3. Looking at my inequality, I have less than or equal to. Notice the equal to there. That means I need a solid line. So I'm going to take my D here, light up my points, and I need a solid line there. There we go. Last step, got to figure out where that shading's at. So 0, 0 is on top. So we're either shading on top or we're going to be on bottom. So we plug in 0, 0. So I have 0 is less than or equal to 2/3 times 0 minus 3. I could plug that all into a calculator if I'm not sure. 2/3, 2 divided by 3 times 0 minus 3. Or just know 2/3 times 0 is 0 minus 3 is -3. So we have 0 is less than or equal to -3. So we got to ask ourselves, is this true or false? If it's true, we shade towards 0. If it's false, we shade away from 0, 0. So the bigger number between 0 and -3 is 0. But my inequality does not open towards the 0. Therefore, this statement is false. So if it was true, we shade on the side towards 0, 0. But since it's false, we're going to shade away from, which is the bottom. And what does this all mean? If you find any point down here, that would be a solution to this inequality. So that was a quick overview of graphing linear inequalities. Be careful with what is solid and what is a dashed line. The actual making of your line is pretty easy. Still use that y equals mx plus b. And then just use 0, 0. You could really use any other point over here. 0, 0 just to me is always the easiest one because it works out nice and clean. If it's true, go towards your point. If it's false, go away from that point. And that, again, was graphing linear inequalities.